So today our topic is isothermal process. An isothermal process is a process in which the temperature of the system remains constant throughout. That is, del T is equals to 0. Change in temperature of the final state and the initial state are 0. Okay, there is no change in temperature. How this happens? We have to recall about the closed state of a system. There are three states of a system, that is an open state, closed state and isolated state. Among this, the closed state resembles a state in which there is free flow of or free exchange of energy between the system and the surrounding. So when some amount of heat enters the system and the same amount of heat goes out of the system, this type of process is known as an isothermal process. So there is no overall increase in the heat content of the system. So we can say here that del T of this system or change in temperature is 0 for this system. As the change in temperature is 0 for any system, if the change in temperature is 0, then the change in internal energy, which is also directly related to the temperature change of the system, becomes 0 as well. Okay, so as delta T is 0, so internal energy change for the same system will be 0. Now, as the internal energy change is 0, we have to go for the first law of thermodynamics. So according to the first law of thermodynamics, what do we know? We know that according to first law of thermodynamics, okay, I'm just writing thermo. We know that del E equals to Q plus W. Okay, so as del E is 0 here, so 0 equals to Q plus W. So W equals to minus Q, or Q equals to minus W. Okay, we will have this type of things. Now, when we are talking about Q or W, what is Q? Q is the heat that we are talking about, that heat which is coming inside or going out, that is heat of the system, and it is directly proportional to the work done of the system, work done by the system or work done on the system, anything. So if this process, isothermal process, is reversible, then one type of work will be done by the system or done on the system. If the process is irreversible, then a different type of work will be done. First, let us understand about the irreversible process. So we'll write here work done in an irreversible isothermal process. Work done in an irreversible isothermal process. Now, whenever we are talking about isothermal process and irreversible process, so we have to understand that the pressure which will be applied to the system will be an external pressure. So we will write here work done, in short W, is equals to negative P. Negative means work done by the system. Okay, and it will be associated with the change in volume. So final volume minus initial volume. Okay, so work done by the system in an irreversible isothermal process is negative P Vf minus Vi, V final minus V initial, where P is an external pressure. Okay, where the P will be an external pressure. So this is work done by an ideal gas in an irreversible isothermal process. Next, we will understand about the work done by an ideal gas in an isothermal reversible process. So work done by a gas in a reversible isothermal process. Okay, so work done by a gas in a reversible isothermal process. The work done, suppose the work is done for a very small amount of change in volume. So if there is a very small change in volume, then we can write it dW means a small change is equals to minus P dV. Okay, this P is it can be an external pressure or the atmospheric pressure, anything. Okay, now the pressure applied, because pressure is also to be constant here. So if we have to integrate, so suppose we want to integrate this. So if we have to integrate this, then what we have to do, we have to understand about where it stands. Okay, P dV. So what is P dV? This P dV, we know that there is a saying called PV equals to nRT, because we are talking about an ideal gas. So this is the ideal gas equation, PV equals to nRT. Now volume is already taken as dV. So we will write here pressure equals to nRT by V. Okay, we will just replace this pressure with this one. Okay, so this is equation 1 and this is, suppose it is 2. So from 1 and 2, from equation 1 and equation 2, we will write that dW equals to negative nRT over V dV. Okay, negative nRT over V dV. Okay, so here what we will do, we will then integrate this dW. What we will do, we will integrate this dW. And here also, as nR constant, nRT is regarded as constant. So I will take out nRT and 1 by V dV. This 1 by V dV, this integration, if we integrate it normally, then we will get an integration constant. But if we integrate it from Vi to Vf, then we will not have any constant of integration. Okay, these are the upper limits and lower limits of integration. So dW will become W, okay, and minus nRT 1 by V dV is ln V. Okay, and here I will write Vi and here I will write Vf. So it will be negative nRT, as negative is thrown outside. So it will be Vf minus Vi or ln Vf by Vi. Okay, Vf minus Vi. When log, if you're subtracting two logarithmic terms, and then it will come, so it will be log Vf minus ln Vf. Ln means log to the base E. Ln Vf minus ln Vi. It will be ln Vf by Vi. Okay, this is all it will come. Now, if I have to change it to log to the base 10, then I will multiply this with 2.303. 2.303 nRT log to the base 10 Vf over Vi. Okay, so this is the work done for an reversible isothermal ideal gas. Okay, work done for a reversible isothermal ideal gas. Understood? Now, the next thing is, this can be also applied for the pressure. Suppose volume is not given, but pressure is given. Then what we will do? We know that according to Boyle's law for an ideal gas, if temperature is constant, then pressure is inversely proportional to volume. So for pressure, okay, if I have pressure value instead of volume value, then I will write W equals to negative 2.303 nRT log to the base 10 Pi by Pf. Okay, because Vf is inversely proportional to Pf. So for Vf 1 by Pf and for Vi 1 by Pi. So Py and Pi by Pf will be your final statement, final form of this equation. So this is how we will do about the work done during an isothermal expansion of an ideal gas. Okay, isothermal reversible expansion of an ideal gas. So this is the complete thing. Okay, in our next topic, we will deal with the adiabatic process. This is the isothermal process. We have derived the formula. Then we will derive the adiabatic process, and after that, we will go for the sums. Okay.